Hi, my name is Nur Hisham bin Isa. So I'm going to talk about the introduction to power generation in electrical system. So for our group, we are talking about the hydro. So what is hydropower generation? In general, the process of producing electric energy or the amount of electric energy produced by transforming other form of energy into electrical energy. For hydroelectric, known as water power, use falling or fast running water to produce electricity or power machines. This is achieved by converting a water source's gravitational potential or kinetic energy to produce power. Next, I will talk about the basic operation or principle of hydropower. The basic principle of hydropower is using water to drive turbines. Hydropower plants consist of two basic configurations, with dams and reservoirs or without. For the first type of basic operation, which is with dam and reservoirs, hydropower dams with large reservoir can store water over short or long periods to meet peak demand. The facilities can also be divided into smaller dams for different purposes, such as night or day use, seasonal storage, or pump storage reversible plants for both pumping and electricity generation. For the second type of basic operation, which is without dam and reservoir, hydropower without dams and reservoirs means producing at a smaller scale, typically from a facility designed to operate in a river without interfering in its flow. For this reason, many consider small-scale hydro a more environmentally friendly option.
Assalamualaikum and hello. My name is Muhammad Irfan bin Muhammad Taib. I will talk about the 6 primary components required in building a hydroelectric generator power plant. The first component needed is dam, pressure tunnel, surge tank, valve house, penstock, and the 6th is power house. This hydroelectric dam is located on or near a water resource. In certain dams, the power house is built on one side of the dam, with a proportion of the dam serving as a spillway to dump excess water during floods. The volume of the water flow and the change in elevation from one point to another is determining the amount of available energy in moving water. Higher change in elevation will result in higher water flow rate. The potential power that can be derived from a volume of water is directly proportional to the kinetic energy of the flowing water. The greater the water flow, the more electricity a hydropower plant can produce. Material required: dam. A dam is a man-made concrete barrier built across a river course. The dam catchment area provides a massive water reservoir. Pressure tunnel. The water is transported from the dam to the valve house via the pressure tunnel. The third is surge tank, used as a pressure neutralizer in hydropower water conveyance system in order to dampen excess pressure variance. Third, the valve house, which have two, that is racing valve and automated isolating valve. When the electrical load is abruptly removed from the plant, this racing valve controls the water flow to the downstream, and the automated isolating valve stops the water flow. The automatic isolating valve is a safety valve that does not affect the flow of water to the turbine in any way. It only works in emergency to keep the system from collapsing. Fifth, penstock, an enclosed pipe that supplies water to hydro turbine and sewerage system, or a sluice gate or intake structure that control water flow. And last is powerhouse, the structure that house generator and turbine at the hydropower facility.
Hello, my name is Muhammad Ismail Anwar bin Muhammad Sufyan. I am going to talk about the related diagram. I will explain about the hydropower plant size and its capacity production. Firstly is the micro hydropower. It can only generate about 100 kilowatt of electricity. In the meantime, it can only accommodate about 200 people. Secondly is the small hydropower. It can produce electricity in the range of 100 kilowatt to 30 megawatt. In the meantime, it can accommodate between 200 to 60,000 people. Finally is the large hydropower. It has the capacity to generate more than 30 megawatt of electricity. In the meantime, 60,000 people can be accommodated.
Assalamualaikum and hi, my name is Nur Najiha binti Asni. I will explain about example of actual site. There is the largest hydropower plant in Malaysia, which is Bakun Hydroelectric Power. It is located in the state of Sarawak in Malaysian Borneo. The Bakun Hydroelectric Power is the largest in the country with an installed capacity of 2,400 megawatt. It's owned and operated by Sarawak Energy since 2017. The Bakun power plant began generating electricity in 2011 and contribute to the Sarawak Corridor of Renewable Energy Score, which aimed to transform Sarawak into an advanced industrialized state by the year 2030. Tenaga Nasional Berhad operates 3 hydroelectric schemes in the peninsula with an installed generating capacity of 1,911 megawatts. At Tasik-Kenya, Terengganu, the Thames Power Station was named as the Sultan Mahmud Hydroelectric Power Station. It's using 4 turbines of 100 megawatts each. Continuous power output is 165 megawatts. At Kemar Highland, Pahang, it is called Ulu Jelai Power Station. It has maximum generating capacity of 382 megawatts. The water from 3 rivers, Sungai Bertam, Sungai Telung, and Sungai Lemoy is used for electricity generation. And the last at Sungai Perak, it is called Temenggo Power Station. It's using 4 Hitachi turbines of 87 megawatt installed capacity and the average annual energy generation 900 million units. That's all from our group. Thank you for watching.